Okay, we're back. I've started this now. I hope y'all are knowing where this is because I think it's great. I'm getting a lot of you to join my YouTube site, subscribe to my YouTube site. I mean, I can't imagine anything uh, that was more exciting for you to do. But um, anyway, just wanted to make sure that you don't try and just find the videos there because from what I've heard, that can be sometimes a little annoying. Or maybe because you're subscribed to it now, it's easier to find them. Just make sure that when you're doing physics 210 stuff, right? Okay, so here we are, physics 210, and so let's get back to the slides here. Okay, mass is the amount of stuff that something is. Okay, Newton's first law. Basically, this is called the law of inertia. Okay, Newton's first law, one more time, law of inertia. All right, an object continues in a state of rest or in a state of motion at a constant speed along a straight line. When something's going to, we'll find when something, and I didn't talk about it because I didn't want to add too much stuff to you that you already didn't, that in addition to what you were learning before. So I didn't add that when we're going in a circle, let me show you something. When we're going in a circle, I think we've talked about this before. Even if you're going at a constant speed, your velocity is always changing and you have an acceleration towards the center. So that's not going in a straight line, okay? Because you do, at each point, you have a velocity towards the center, and that's called the centripetal force. And we'll get to that a little bit later. Right? Excuse me. All right, so now, back here. So the net force is the vector sum of all the forces acting on an object. So unless something is acted upon by a force, now what we're talking about is in an inertial reference frame, and we're going to use our classroom as an inertial reference frame. What is he saying? All right, this is what we're talking about. Newton's first law. Having trouble writing. First law. Law of inertia. Okay. Now, this means that an object way out in, you got to just imagine an object way out in deep dark space. It's moving along. It's what is known as an inertial reference frame. Okay. That means acceleration is equal to 0. Deep dark space has no acceleration. Maybe it does because dark matter seems to be spreading it out. But for our purposes, for Newton's purposes, an inertial reference frame means the acceleration is equal to 0. And for some reason, we call for physics 210, we allow for our classroom to be an inertial reference frame. It's actually a non-inertial reference frame. Why? Because gravity is acting in there. Why? Because the Earth is moving around the sun, which also creates an acceleration. Okay? So there's all kinds of acceleration going on, but for our purposes, we kind of treat it as an inertial reference. In other words, we go, okay, just to so we can do things, we're just going to say anything that happens on Earth, the starting, what we're going to start with is that there is going to be an acceleration due to gravity. All right. But in an inertial reference frame, Newton's first law is the law of inertia. An object will go in motion in a straight line at a constant speed unless acted upon by an unbalanced force. Okay? It is not F equals ma. It is just saying that once an object is moving, if I've got a ball that's moving out, and say the velocity is equal to 2.0 times 10 to the 5th meters per second. It's flying along in deep dark space at a constant speed. It's going to go that way unless acted upon by an unbalanced force from somewhere outside of it. The object itself does not create the force. As a matter of fact, if you're on the space station, which is in a zero gravity situation, and you need to cross a room, you can get stuck. Okay, you can get stuck because you're floating. And then all of a sudden, if you get too far away, it's not designed this way, but you could wind up getting too far away to grab anything, and there's nothing your body can do to contort yourself so that you so that you can get moving. So it's outside forces. Constant speed or zero or at rest, which I consider at rest a constant speed of zero. So constant speed still works. At a constant speed, one direction, until acted upon by an unbalanced force. 1 second.